Now let's see this shortest job first. So the name itself says that whichever is having the least burst time, we are going to schedule it first. That is why it is shortest job first, and it is of two variations. One is preemptive and the other one is non-preemptive. And coming to this one, here I am using non-preemptive, which means whenever any job is chosen, it will not stop until it finishes. That is why it is called non-preemptive. And the other one is the preemptive version is there, which is also called as shortest remaining job next. That one we shall see it. Okay, we shall see it later. But now we shall confine ourselves to the non-preemptive version. So what does it mean? Whenever you choose any process, you are going to run it till completion. Otherwise, you are not going to stop. Okay. Now let's see how to do this. First one is like this. First one is I am going to use the Gantt chart starting at 0. So at 0 is any process available? Arrival time is minimum is 1. Therefore no process is actually available at 0. So until 1. So the first process which will be available will be at time 1. Therefore from 0 to 1 CPU is idle. Now at time 1 the only process available is P1. Therefore I am going to take P1 and run it till completion. The reason is it is non-preemptive version, right? So how much time does it take for it to complete? 7 units. Therefore it is 1 plus 7 is 8. So now the time is 8. By the time 8, all the other processes are available. In case if they are not available, then you have to pick one of the available processes for the scheduling. Always remember this. Whenever you are trying to pick the next one, you see that you pick the next available process for scheduling, right? And now 1 to 8 is over. Therefore you have to pick one from the available one, right? So from all these, which one is the least one? From all these, the least one is P3. See, P1 is over. Therefore the least one is P3, which is having a burst time of 1. Therefore I am going to take P3 next. P3, it is having a burst time of 1. Therefore it is going to be running till 9, right? Now P3 is over. Then what is the next one with the least burst time? Which is 2. Therefore P4, which is having a burst time of 2, therefore the completion time is 11, right? And now I have 3. One is 2 and other is 5. I think I have 2 processes. 1, 3, 4 are over. 1, 3, 4 are over. I have 2 and 5. And in these two, which one is having the least burst time? If you watch it, the least burst time is at P2. Therefore I am going to take P2. And whose burst time is 5, therefore 11 plus 5 is 16, and obviously only one is remaining and it is already available at 16, right? P5, which is 8. Got it? So 16 plus 8 is how much? 24. Okay. Now if you observe it, even though it is shortest job first, when you have these many jobs, the question might be, given any schedule, given any random combination of process with random possible arrival times, our shortest job will always schedule the shortest job first. It is false. The reason is it is actually scheduling among the available process the shortest job first, which means when you are standing at time 1, at this point of time 1, only process which is available is P1. That is why it is chosen, but it doesn't mean that P1 is the shortest job, right? Therefore shortest job works in such a way that among the available process it is going to take the shortest job. It doesn't guarantee that whatever is the arrival time, you are always going to start with the least job first. No, right? Therefore in this case it is 7. So what happens is sometimes even shortest job first will also fall a victim to convoy effect. I mean, it is not mentioned in any of the textbooks, but then I observed this. The reason is if the longest process, which means the process with the highest burst time, largest burst time, arrives earlier, a bit earlier compared to all others, right, then obviously you are going for this one, right? Therefore shortest job first is also a victim of convoy effect. The reason is, I'll just show this example. I think you understood this. Okay, let's finish it off. Then I'll show you what is the problem with this SJF, shortest job first, and then we can continue with the next algorithms. Okay, one more thing. How do you think that they implemented this? I mean, if you are trying to implement this program, you have to design the algorithm, right? Yes, algorithm works this way. Then what is the data structure which supports this algorithm? If you think about it. Now, among all the available processes, I might have to pick the least one, which means the one with the least burst time. Therefore the min heap is suitable data structure for this. The reason is, in min heap you can find the minimum as well as delete the minimum. Once you delete it, you need not again recheck it, right? So what we do is, as and when any process arrives, we are going to add it to the min heap, and the heap is maintaining the min property based on the burst time. Therefore always the root is going to be the process with the least burst time, and we are always going to remove it and then schedule it and then throw it out, right? That is why min heap is the best data structure here, right? And if you watch it in this one, in the min heap, one process will be added exactly once and deleted exactly once. Therefore for every process there will be one addition and one deletion. If addition is going to take log n time, adding an element in the min heap, and deletion is going to take log n time, right? Then n into 2 into log n. Therefore n log n is the time complexity for this. Okay, don't worry about that. Please refer to that algorithms, min heap, and then come back and watch it. If you didn't understand what I'm saying, you please go to the algorithms, watch it, and then come back. Now let's see about the completion time. When did each one complete? P1 completed at 8 and P2 completed at 16, P3 completed at 9, P4 completed at 11, P5 completed at 24, right? So after that you can find out the turnaround time. Then what is the turnaround time? I told you that turnaround time is completion time minus arrival time, the difference of these two, right? Then what is it? It is 7 here, and it is 14 here, and it is 6 here, and it is 7 here, and it is 19 here, right? It is the turnaround time. And after that you can find out the waiting time. So what is waiting time? I told you that waiting time is turnaround time minus burst time. Anyway, see, you can do all this very easily. These are the simple trivial things, right? Even though I'm doing it, you can do it yourself. So for those who are not able to do it, I'm just doing it. And 14 minus 5 is 9, 6 minus 1 is 5, 7 is 5, and if there are any mistakes in the numericals, you please use your good judgment. And it is 11. There is nothing like this, right? And then they will ask you what is the average turnaround time and what is the average waiting time. Got it? So that is how you can schedule it. So here also you should be careful that when you are standing at any point, just see what are the process available. Don't directly go and pick up the last, one with the lowest burst time. Right? I'll show you more examples on this also. Then you'll understand it.